Page 645 starts the chapter. It's on files and streams. I mentioned this term to you before. You should at least be familiar with it, and that is data persistence. If every program that we have run thus far, everyone, all right, when you stop the program run, whatever you had figured out for your output is gone. Bless you. All right? So if you want data to persist between runs, you've got to do it in one of two ways. This chapter discusses files and streams. Starting next week, we will discuss the other way, which are databases. All right? So if you look here, I'm not going to read these to you, but they talk a little bit about how files are set up, what you have to do with files. This is again where things like exception handling become important. If I try to open a file and the file doesn't exist, that's not a good thing. So as we start to peruse our way through this, you may have heard of this stuff already. I'm sure that there are people in this room who are much more hardware savvy than I am. All right? But they talk about in here that basically, as it says, when you say, how much RAM do you have in that machine, etc. All right? Well, RAM is volatile. So in other words, it's subject to electronic current. It's a lot nicer these days, that many of you probably come in here, and if you charge your computer before you come into class, you might have enough battery life that you don't need to plug it in anymore. All right? Maybe you've seen even the commercials for like a Google Chromebook. I know my daughter has a Chromebook, my youngest daughter, and she does, it seems like it does run pretty long. All right. It used to be that basically the battery on a computer was almost non-existent. When I worked at my old job, everybody, you'd be plugged in, and if you didn't save regularly or set up autosave, they had an electrical power distribution program at that campus. So they were always digging at the end of the campus, and occasionally they'd dig something up where they'd hit a power line. Boom, the power would go, and you'd hear a bunch of people shouting F words because they just lost everything they were working on. All right? That's not that big of a thing today. But we do want to work with permanent file storage, which is non-volatile. All right? So when you work with files, there's two basic kinds. There are text files and there are binary files. What's the difference? Well, you already probably know this, but if I come through here and, for instance, if I go into Notepad++ right here and I do a file open and I go to my desktop and I try to open up this file, why does it look like that? Why does that file look like that? Anybody? It's because I'm trying to open up a binary file, all right, just what we're talking about right here. I'm trying to open up a binary file using a text editor. And the system doesn't know how to handle it. So it shows it the best way it can, all right? But a text file you can open with a regular text editor. Notepad, Notepad++. I think it's Wrangler if you're using a Mac, etc. All right? With binary files, as it says, they have not been encoded as text. So a text editor cannot understand them. All right. A couple things about files they mention here on 647. Again, I don't want to read to you. The big thing, though, is files, not that they just have a name. Typically, when you have a file, they have permissions. So if I've got read permission for a file, I can read it, but I can't change it. All right? If I've got write permission for a file, that typically means I also have read permission for it, so I can read it and change it. All right? You may or may not have noticed when I showed you this before. Did you notice this? Because this is something actually that's not real new, but fairly new from Microsoft, and that is support for putting in forward slashes. It used to be when you did it like this in Microsoft, you'd have to put in 2 backslashes. Remember, backslash has a special meaning. Backslash N is new line, backslash T is tab, etc. So if you wanted to actually show a backslash, you had to put it in there backslash, backslash. Putting it in with a forward slash like this is the way it's typically done, like in Linux. But Microsoft now supports that for stuff like this. All right. So if you look up on page 648, they talk about the main classes, the main methods in the file class. All right. Create, which creates any kind of file. Create text for a text file. Delete. This is an important one right here. Exists. You typically want to run the exists method before you do a file operation. Before you try to open a file, you should make sure the file's there. All right. If it's already open, you don't have to check it before you write to it or close it. All right. But you typically want to run the exists method on it. You can move files around. A lot of the stuff that they talk about doing in here are things you're like, well, can't I just go do that in Explorer? Or can't I do that in DOS or whatever? Yes. But they're talking about being able to do some of this stuff right within a C# program itself. So here's an example here on 649. Notice that when you work with files, you're virtually always going to add that using statement shown at the top there. Using system.io, where I/O stands for input-output. And again, before they're doing something with the file, they're checking to make sure it exists. Here are some directory or folder class methods. I'm not going to read those. You can see them there on 650. All right? And every time the author shows you this, basically every time, she shows you a small program down below. This is kind of a neat program because what it does is it'll check to see if you've got a folder on your system, and if you do, it'll tell you all of the files that exist inside of it. But it's a C# program. Again, it's similar to you going into Explorer and just looking at everything that's in there. Now they show you here file organization. Why is this important? Because this is also basically database organization. In a database, you've got a group of characters that make up a field. You've got a group of fields that make up a record. You've got a group of records, but a database, rather than saying that it makes up a file, it makes up a table. So this picture that you see right here, if we change the word file up above here to the word table, it would be describing a database as opposed to describing a file. And they explain what each one of these mean in here, a field, a record, etc. on page 652. All right. All right, the next thing they talk about is sequential access versus random access. Now, you're probably all too young to know about this, but back when I was younger, before we even had CDs, all right, we had cassette tapes. And if I was listening to a cassette tape on my cassette player, and I wanted to listen to song number 8 that was on a cassette, and I was at the beginning, I'd either have to listen to the first 7, or I'd have to fast forward through the first 7 to get to the 8th one. Why? Because when you use that, it was a sequential access file. All right. Then came the advent of things like CDs, where you could just punch in a number and jump right to it. That's random access. All right. So sequential access, there are a lot of different programs that are out there that use sequential access all the time. Payroll programs, which very rarely change, are almost always done with sequential access. All right. But if I worked, for example, for an insurance company, and I was always, I was writing programs for them where they were always adding new people, deleting people, changing people's address, changing people's coverage, changing who is covered, etc. I wouldn't want to use a sequential access program. I'd want to use a random access program. All right. When you use a random access program, every record that's in there must be exactly the same size. All right. Why does that matter? That means if my name is Joe Smith, my whole name, Joe space Smith, all right, and I got somebody else whose name is really long. All right. I always remember my I don't know why, but my high school history teacher, Mary Ellen Schadenberger, which was really a long name. You have to use the same number of characters for Mary Ellen Schadenberger as you would for Joe Smith. All right. Why? Because the system has to know exactly how big each record is, so it can jump from record to record with random access. All right. As it says, before you can use a file, you open it. When you're done with it, you should close it, meaning you don't need it anymore. If you run a program and you open a file, but you forget to close it, or for whatever reason, you just don't close it, all systems are set up to automatically close it for you. All right? But it's still considered a best practice that when you're not using it anymore, you should close it. All right. Now, where this gets a little bit hinky, for lack of better words, and you're going to see this again, because the way they do this is very similar to the way Java does it. And that is on page 654 in your book. It says, whereas you and I view files as a sequence of records, with each record containing fields, C# views files as a series of bytes. It's kind of like this. This is meant to show right here, if you take a look at it, kind of like water flowing through a system. So it flows in as input, it gets processed, it flows out again as output. That's what they're trying to show right there. All right? But again, typically at least, you and I aren't going to look at it that way because there's really no reason for us to look at it that way. All right? Everything that we've done so far, when you think about it, we've used the console. Our input device has been using the console. We key something in, or we click something with a mouse, but that's virtually everything we've done. Our output has been the screen, whether we were running a console application or we were running a GUI application. And our error was also the screen, but none of them have to be. In fact, typically when you're using a file program, either your standard input or your standard output, or both, won't be the computer itself. It'll be a file. And that's what they're trying to talk to you about right here. So it says when you need to read from or write to a file, you use a file processing class rather than the console. So if you want to read stuff from a file, you use a stream reader. When you want to send stuff to a file, you use a stream writer. All right? And you combine those with what's called a file stream. So when you do this, if you look here on the bottom of page 655, the author shows you different things that you can or cannot do. Some of the different properties of a file stream object. Going along with that, there's different file modes. Again, I've given this example before, but if I work at a bank and I'm a teller at a bank and you come in, James comes in and says, what's my balance? I can look it up. All right? But if he comes in and asks very, very sensitive, private information, I probably don't have access to that. So different people can have different types of access to different files, just like they can to different databases or different tables within a database. Typically, the three things that are associated, there's read, there's write, which means read only, all right, and write only technically, and read write, which means you can do both. And again, as always, she shows a little picture here on page 657 that goes through this. All right. Now, on 658, I just want to give you a term. Believe it or not, some of this stuff you're still asked at interviews. All right. But here it says reading and writing a sequential access file. So let's pretend for just a second that we're working someplace where we've got 10,000 records. All right. Somebody comes in and says that record 3,718 needs to be updated. All right. And this is a sequential file access program. You can't just sit there and say, hey, jump to that record, change it, write it back, and boom. You can't do that with sequential files. What you've got to do with sequential files is you've got to take the first 3,717 records, write them to a new file, fix record 3718 and write it to a new file, and then finally write 3719 through 10,000 to a new file. So in other words, what you cannot do with sequential access, you can't do what's called an update in place. That's actually a question. If you work for a company that does sequential file processing, you could be asked that at an interview. All right. What is what is update in place? Just give me an example. That is an example. All right. And again, there are a lot of places out there that use sequential access file processing. All right. If you turn up all the way, please, to 664, the author has got one of her infamous you do it's. So as it says, you create a file with a list of names. Notice how you do this. You set up a file stream. All right, that's going to be the name that you're going to use. Then you set up a stream writer. So you want to be able to create the file. Here you want to be able to write to the file. Here are the names that you're going to want to write to the file. And she actually shows you the code for doing it. Look at how this changes. All right, we've just used write line, right? Remember how we've been using static system.console? Well, look how this changes. I mentioned that if you just put using system, we have always, or you could say something like console.writeLine. Now we're saying writer.writeLine, which means write it to a file that's referred to as writer. All right. So that's on 664, 665, 666, and 667. On the bottom of 667, they talk about how you search a sequential file. Okay? And you've got to start from the beginning, and you can go search your way through it. Imagine, again, if you had a phone book and you were searching for John Smith, but you had to start with the A's and you had to go in order and search every name. That would be kind of ridiculous. All right, you could do it, but it would take you a lot longer. That's what they're talking about in here. Again, she has another you do it on 670, 671, 672, and 673. All right. Bear with me, we're almost done. On 673, on the bottom of the page, the author discusses again. These are terms that I have had students that have applied for Java positions have told me they have been asked this question. What is serialization and deserialization and the difference between the two? All right. So as it says right there, the bottom line is this. if you're writing something to a file, to whatever you're writing it to, and then you're going to send it over the internet, if the file is super humongous, it can't all be sent at one time. If you know anything, and again, some of you I'm sure know more than I do about this, about the hardware side and sending stuff, data basically is broken up into packets. Those packets are, so you take your data and you disassemble it into packets. You send those packets over the wire, then they have to be reassembled again. That's what they're talking about in here with serialization and deserialization. So as mentioned on the top of page 674, it says serialization can be used for writing objects to and reading objects from data files. So serialization converts objects into streams of bytes. Deserialization sends them back again. So again, if I'm going to send something over the internet, I serialize it to break it up, and then on the other end, when I want to put it back together again, I deserialize it. She gives an example. This is about as heavy as it gets in this book on pages 675, 676. And then she shows, after you do this, what it's going to look like on the next page. There's one more you do it on 678, 679, 680, 81, 82, 83, 84, and 85, and 86, which goes through the entire process. All right? That brings us to the end of the chapter, and I don't normally do it like this, but before we go over the review questions, because I'm not sure if I have them with me or not, my answers to them, let's take a break. It's 9:40. Let's please come back at 9:55, and at that time we will go over the review questions that start on page 689.